I've had this meter, I have two of these, for many, many years. Bought them back in Radio Shack when they were in business. It always read the line voltage fairly accurate, but for the last year or so, I kept them plugged into the shed outlets, just so I don't lose them. And for the last, I'd say 6 or 8 months, it was reading all the way over to 130 volts, which is not normal. My line voltage is never over 120. So, we're going to open one of these up, and we are going to see what we can do to modify it. It can't be very much to modify this the tinkerer's way. I'm going to tinker around here. I had this for years. I have two of them, and they're reading high now. They're reading all the way over to the right. Let me plug this in. I opened it up. You know what me with microelectronics. I tried pushing this out. All I'm going to do is break the board. So I'm going to experiment with this. Why not? I am a tinkerer after all. I have no idea what is in here. I thought there might be an adjustment in here where my thumb is pointing right there, that little tiny hole. But the smallest of screwdrivers, flat blade or Phillips, don't seem to do anything. So you can't remove that without breaking it up. So what I'm going to do, experiment with the meter movement with some resistors. We're going to unsolder these wires here, and I'm going to play around with this. I'll get you on a tripod, but I want to show you what it's doing now. So I got to snap this back together because I need two hands to do that. I'll plug it in to the kilowatt, which is showing the actual line voltage. I wish our line voltage was that high. Now these things are always plugged in to the shed just so I don't lose them, but that's incorrect and there's no adjustment for it. This is the line voltage we got right here today. No AC's running. Okay? So, what I am going to do is I am going to play around with this. I'm not expecting any success, but let's give it a try. I don't know if the meter movement is AC or DC. I'm going to probably say it is DC, but what I'm going to do first, I'm going to power this thing up with it open and try to read the voltage that this meter is seeing itself, the actual meter movement, whether it's AC or DC. Can't be very much, and it may not even be readable, because what it's probably doing is reading current across the resistor. But we'll see. We get an idea whether this movement is AC or DC. It could be either. Now, we don't know if there's a diode in here or not, but let's unplug it. Now, it's nothing fancy, it just gives you the line voltages. So there's nothing below 100 volts that is marked. You're supposed to normally be in the green. But let's just find out. Let's do some experimenting. All right. Of course, you're not going to be able to see the meter because I can't do picture-in-picture. So, you take my word for it. Let me measure across this. I got to get my face on. Just let me try to move this over here a little bit. Oh, everything's falling all over. very hard to video this stuff here. Take my word for it, and you're not going to be able to see the meter. You're going to have to just rely on what I tell you here. Now it's going from volts to auto, back and forth. So it's not telling me anything. It's flashing on auto, volts, all zeros, and the meter off. Turn the meter off here. All right. Well, between here and here, the meter was flashing auto. It looked like it said AC, but it was saying volts, and then it was going off of volts and saying auto, and going back and forth, back and forth. So whatever this meter is getting here, I still don't know what would make it move. So what we're going to do is we're going to unsolder these two wires off of this. We'll come back in a minute. I've unplugged it. We don't want any disasters here, and we're going to unsolder these two wires. So what I'm going to try to do is to rip out some of the circuitry in here, because I can't get this board out. This board is soldered to the lugs which hold these in, and these are tight because it's made to go into an outlet. So this is like put together one time, goodbye Charlie. You know how that is. So we're going to unsolder this. I'm going to put this iron on now. Always got a gargle in my voice. That's why I'm always clearing my throat all the time. I never had that years ago. All right, let me just get back to you in a minute here. We're going to try something. All right, we unsoldered it. This is what I do with microelectronics. I want to get everything out of circuit, but I want to leave the connections to the thing. I have no idea what's in this. We just cut it out so that we got a diode in there I can see, but I have no idea how it's hooked up because I can't see how it's in there. All right, make sure there's no other components. We'll trim this a little bit here. You can see why I don't work on these things, huh? I got nothing to lose. The damn thing's no good anyways. So now, what I want to do, I'm going to try to, I still don't know if it's AC, but it don't matter. If it's AC, we still can do it. We can connect it directly to the line with a high resistance in series. We should be okay. Because apparently the meter movement works. It's just that it reads wrong. Because something in here went bad. I have no idea what the hell this stuff is. There's a chip in here. Yeah, there's an adjustment here. But it always was reading fairly close. All the time, all of a sudden it's reading very high. So obviously something was crap in the bed along the line here, so we're going to clean this up and I'll be back. All right, I got a 100 meg resistor in series with the meter and the line cord. I don't know if you can, it's not plugged in by the way. I don't know if you can see that. You got a reflection on that. That is a resistor I got from eBay a number of years ago. And we're going to try this. We're going to plug it in. But we got to be very careful. We don't short these things out with my Rube Goldberg setups that I have here. So now the 100 meg is the highest resistance I have, and I'm almost certain it won't damage the meter. The only thing is, I don't know if the meter is that circuit board that I chopped up, whether that comes out DC or AC. My digital multimeter kept flashing AC volts and then back into auto again. AC volts back into auto. So it was probably so low that it wasn't picking it up. Well, here it goes. I'm going to plug it in. Of course, naturally, do you ever notice no matter when you plug a plug in the wall, if it's not a 3-prong and it's a regular one like this, it's always wrong and you got to turn it around? That happens to me all the time on USB flash drives and cords. The first time you try it, it's wrong and you got to turn it around. All right, here goes. Nothing. All right. Before we change the resistor, let's put a diode in there. We'll leave this resistor here. We'll add a diode just in case it's a DC meter. All right, I have to move the stuff here. I got a 1N4007 here in series with the line. It don't matter, the hot side or the neutral, don't matter. It's in series with that, in series with the resistor, as you can see here. And before we plug it in, we're going to move it back so you can see the meter. And we're making sure we're not shorting out here. We're moving the stuff out of the way here. All right, cords are not going to short out. We don't want you to see the meter. We'll plug this in. Now, oh boy, here comes everything sliding. My Rube Goldberg, you know. If we get a negative deflection, then we just reverse the diode. And if that don't work, then we'll get a 10 meg resistor. I don't have anything in between unless I put a whole bunch of 10s in series. There we go. You got to reverse the plug. It never goes in the first time. I'm trying to find a plug to go in. Let's see. Nope. Okay. So 300 meg is too high. This is what I do. I experiment. Don't do Ohm's law. I can't read the resistance of this meter. I could damage it, blow it out, trying to put an ohm meter on it. Remember, the ohm meter that I have, the new one, has 3 volts. Now, if you put 3 volts on the ohm meter into here, you could damage it. I could try the diode check. I'm not going to do that. 2 10 meg ohm resistors in series. They just happen to be from the last test I made. So we get this back up here. All right, so we're still got the diode connected. Needle is moving forward. Tiny bit. Okay. All right, what I did is I took the diode out of the circuit temporarily here. I don't know if it's in camera or not. I can't tell. I'm not going to worry about it. I got to be careful I don't short anything out. Take my word for it. I got two 10 meg ohm resistors in series, but this time the diode's out of circuit. I wanted to see if there's any difference in the change. If we're still getting a slight forward movement on the meter, then that means there is a diode in here already. So adding a second one is not necessary, but let's just see. No movement, so it's an AC meter and it needs a diode. So what we're going to do is we're going to go down to one 10 meg. Right now we got two 10 megs in series. We're going to drop down to 110 meg. This is how I do it. I don't worry about any formulas. This is how I always work. Experimentation. That's why I'm a tinkerer. Hang on. Okay, watch the meter. I got one 10 meg in series, and I got the diode in circuit. Yes, we are getting a reading. So now it's a matter of picking out the right resistor, which will get calibration on this, and we'll use the kilowatt for a reference. I don't know why they need all that other stupid circuitry when all you need is a resistor and a diode in series. Now there was a diode on that board, but it's impossible to get the board off without destroying it, and something was wrong on the board anyway. So, all right. Now we're going to figure out, okay, we got 10 meg in there. Let me say now, we're getting a little bit of movement, so let's try to get something around maybe 3 meg, if I have it. I hope I don't have to go into my mixed resistors. I'll be here all night. I didn't have a 3 meg, and I do have one in the mixed. I'm not going to spend all night looking, so we got 3 1 megs in series. So I think we're safe. I don't think we're going to peg the meter with 3 meg. I don't think so. If it moves a little bit with 110 meg ohm resistor, I would say it probably roughly, I'm guessing, about halfway to scale. So let's try that. I'm looking here to make sure there's nothing shorted. Well, there we go. We're getting somewhere. All right. Let's unplug it. On camera, let's go down to 2 meg. All right. Let's go down to 1 meg. I unplugged it, by the way. Got to be very careful not to short anything out here. Yeah. Now, with our line voltage, that could be about right. I think 1 meg. I can't see that from the angle I'm looking at. I got to be careful. I can't turn this around because these leads could short out and will blow out the diode and the meter, or at least one or the other. So I'm turning it so I can see it. Now I can see what my voltage is. 110, 15, I'm not sure. Let me Zoom you in there. Alright, you got a shadow, it looks like, but I think you can see that. Take my word for it, I'm going to look at the kilowatt. My magnifier. 116.5. 116.5. I don't want this thing reading higher and give me false readings on my line voltage. 116.5. So let me stop the video a minute and unplug this. Alright. Kilowatt is reading 116.2 volts. 116.2. The new meter's reading 116.5. Okay. What are we reading on this? Gotta be very careful I don't short these wires out. I'll be back. Close as I can read that, I think that's increments of 2. It's reading 114. My line voltage is 116.1 right now. It varies. And 116.0 on the kilowatt. So, yeah, it's increments of 2. 110, then 112, then 114, and 116. 12, 14. Now, right now I'm reading 114. So we got to get another resistor that's going to give us about the same. The fraction you're not going to get. So let me stop the video and try to get a resistor that'll be less than 1 meg. This is going to be a job because I don't want to go through the mixed resistors. And I don't have a potentiometer that small like in that higher resistance. I'll be back. Well, what if I stick a 10 meg across to 1 meg? It's worth a try, isn't it? We're not plugged in, by the way. Be back. Here is 894,000. 10 meg shunted to across a 1 meg. So I'll get back on the camera here just a minute. 116 volts. 116.5 on the kilowatt. That's as close as we're going to get without me going in and fine-tuning it. So that's what we've got here. And I think we'll put it together. All right, we got it made up. We're not soldered yet. All right. Not a good job, but it's the best I can do for small stuff like this. What we got to do is just insulate that, solder these wires back onto the meter. I hope you can see that. 116 even. That's close enough. 110, 12, 14, 16, a hair over 116, close as I can read it with my eyes. Okay, we'll close it up. We got to button it up here, and we won't do that on camera. We'll do that off camera, get it all together again. I don't think I need a fuse in it. There wasn't any in the other thing, I don't think. Should be all right. I don't have any fuses that small anyways. Okay. We'll be back. Okay, there we are. Not a very neat job inside, but the main thing is it works and it looks good on the outside. That's it. Just the tinkering, fixing up of a meter that was reading way too high. And I have no idea why, but something went wrong in the circuit board. I don't know why they didn't use a resistor and a diode like I did, instead of all that complicated circuit. It's working, and that's all that I care about. Thanks for watching. Take care, everybody.